my dear friends. In this video, we can study glycolysis. Glycolysis, first we can study the steps. First step is glucose is converted into glucose 6-phosphate. That is the first step in glycolysis. Glucose is converted into glucose 6-phosphate, and this reaction is irreversible. That means this one is a regulatory step that we can study later. Then this glucose 6-phosphate is converted into fructose 6-phosphate. Glucose 6-phosphate and fructose 6-phosphate are isomers, and this step is a reversible step. That means fructose 6-phosphate can convert back into glucose 6-phosphate. And next, this fructose 6-phosphate is converted into fructose 1,6-bisphosphate. Fructose 6-phosphate is converted into fructose 1,6-bisphosphate, and this step is irreversible. Okay, this step is irreversible. That means this one also a regulatory step in glycolysis. Then this fructose 1,6-bisphosphate, which is a 6-carbon compound, converted into 2 molecules of 3-carbon compounds. That is dihydroxyacetone phosphate. That is a 3-carbon compound. It is 96%. Okay, 96% of 3-carbon compound is dihydroxyacetone phosphate. When fructose 1,6-bisphosphate is converted, 96% is dihydroxyacetone phosphate, and rest is glyceraldehyde 3-phosphate. And these steps from 1 to 5 is known as preparatory phase. Glycolysis, there is 2 phases, that is preparatory phase and payoff phase. Now we can study enzymes. Glucose is converted into glucose 6-phosphate with the help of hexokinase. Kinase. What is kinase? It transfers phosphoryl group between ATP and a metabolite. Transfer phosphoryl group between ATP and a metabolite. Here metabolite, which one is the metabolite? Glucose. So it transfers phosphoryl group into glucose. Then it becomes glucose 6-phosphate. Okay. Then kinase always need a cofactor. That is magnesium 2+. Kinase always need magnesium 2+ as cofactor. Then, and here the reaction is phosphorylation. Glucose is converted into glucose 6-phosphate. The reaction is phosphorylation. Then glucose 6-phosphate is converted into fructose 6-phosphate. Which is the enzyme here? These are isomers. Glucose 6-phosphate and fructose 6-phosphate are isomers. So, enzyme is isomerase. Phosphohexose isomerase is the enzyme. We can also call it as phosphoglucose isomerase. Reaction is isomerization. This step is reversible. Then next is fructose 6-phosphate is converted into fructose 1,6-bisphosphate. Which one is the enzyme? Phosphofructokinase. Phosphofructokinase. Kinase is here. So reaction is phosphorylation. That means here also the transfer of phosphoryl group between ATP and a metabolite. Cofactor magnesium 2+. Kinase always need magnesium 2. So here also ATP is converted into ADP. ATP is converted into ADP. Reaction is phosphorylation. With the help of this phosphofructokinase, ATP is converted into ADP, and fructose 6-phosphate becomes fructose 1,6-bisphosphate, and this step is a regulatory enzyme that is specific to glycolysis. Okay, that we can study later. Glucose 6-phosphate to fructose 1,6-bisphosphate. Then next one is fructose 1,6-bisphosphate is converted into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate with the help of aldolase. We can call it as fructose 1,6-bisphosphate aldolase. Reaction is aldol condensation. And this dihydroxyacetone phosphate can converted into glyceraldehyde 3-phosphate, and glyceraldehyde 3-phosphate can convert into dihydroxyacetone phosphate with the help of isomerase, that is triophosphate isomerase. Enzyme is isomerase. So what will be the reaction here? Yes, isomerization. Dihydroxyacetone phosphate is converted into glyceraldehyde 3-phosphate with the help of triophosphate isomerase, and this step is known as preparatory phase. And next is payoff phase. That means, and this phase yield ATP and NADH. That is payoff phase. Energy is produced in this phase. And here we can study the steps first. Glyceraldehyde 3-phosphate, that is a 3-carbon compound. It is converted into 1,3-bisphosphoglycerate, and this reaction is also reversible. Okay, reversible means that is not a regulatory step. Glyceraldehyde 3-phosphate is converted into 1,3-bisphosphoglycerate. This is the first step. And here 2 molecules of 3-carbon compounds. That means one glyceraldehyde 3-phosphate is converted into a pyruvate, and then this dihydroxyacetone phosphate is converted into another molecule of glyceraldehyde 3-phosphate, and this one is also converted into pyruvate. So glyceraldehyde 3-phosphate is first converted into 1,3-bisphosphoglycerate. That is a reversible reaction, and this one is then converted into 3-phosphoglycerate. This one also reversible reaction, 3-phosphoglycerate. Then this 3-phosphoglycerate is converted into 2-phosphoglycerate. 3-phosphoglycerate is converted into 2-phosphoglycerate, and this reaction is also reversible. That means this one is also not a regulatory step. Then this 3-phosphoglycerate is converted into 2-phosphoglycerate. Just a position change. 3-phosphoglycerate is converted into 2-phosphoglycerate. Then this 2-phosphoglycerate is converted into phosphoenol pyruvate. This one also reversible reaction. Phosphoenol pyruvate. 2-phosphoglycerate is converted into phosphoenol pyruvate. Then comes the last step, that is phosphoenol pyruvate is converted into pyruvate. Phosphoenol pyruvate is converted into pyruvate, and this step is irreversible. That means this is a regulatory steps. So here 3 regulatory steps. Okay. Now we can study the enzymes. So total 10 steps in glycolysis. Glyceraldehyde 3-phosphate is converted into 1,3-bisphosphoglycerate with the help of glyceraldehyde 3-phosphate dehydrogenase. Enzyme is glyceraldehyde 3-phosphate dehydrogenase. And here the reaction is oxidation reduction and also phosphorylation. So here one molecule of NAD is converted into NADH plus H plus. This one is a energy yielding step. So the conversion of glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate is a energy yielding step. Okay, phosphorylation steps and also oxidation and reduction is taking place. NAD is converted into NADH plus H plus in this step. Enzyme is glyceraldehyde 3-phosphate dehydrogenase. Dehydrogenase is the enzyme. And then this 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate. 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate with the help of phosphoglycerate kinase. Phosphoglycerate kinase. Kinase is there. That means phosphoryl group transfer. Okay. Which is the cofactor here? Yeah, magnesium 2+. Here, one molecule of ADP is converted into ATP. This is the first energy ATP yielding step in glycolysis. ATP first, OX substrate level phosphorylation, where from 1,3-bisphosphoglycerate to 3-phosphoglycerate step, one molecule of ADP is converted into ATP. Enzyme phosphoglycerate kinase. ADP is converted into ATP. Okay. ATP, that is substrate level phosphorylation. Then this 3-phosphoglycerate is converted into 2-phosphoglycerate. You can see here 3, 2. That means a position change. Okay, position change. That is phosphoryl shift. Which is the enzyme here? Position change. Phosphoglycerate mutase. Mutase is the enzyme. Phosphoglycerate mutase is the enzyme. 3-phosphoglycerate is converted into 2-phosphoglycerate. Enzyme is phosphoglycerate mutase. And reaction is phosphoryl shift. And this reaction is reversible. Then the 2-phosphoglycerate is converted into phosphoenol pyruvate. Phosphoenol pyruvate. Enzyme is enolase. Here, one molecule of water is released. So, which is the reaction? Dehydration reaction. Enolase catalyzes the formation of enol phosphate. And which is the cofactor? Here also magnesium 2+. Dehydration reaction. The enolase promotes removal of water from 2-phosphoglycerate to yield phosphoenol pyruvate. Then this phosphoenol pyruvate is converted into pyruvate. Enzyme is pyruvate kinase. And here 2 cofactor, magnesium 2+ and potassium. So kinase is here, that means phosphoryl group transfer. One molecule of ADP is converting into ATP. This is second substrate level phosphorylation in glycolysis. ATP is converted into ADP is converted into ATP. So 2 molecules of ATP is formed from glyceraldehyde 3-phosphate. And you know, the other molecule of dihydroxyacetone phosphate is again converted into glyceraldehyde 3-phosphate, and in the second step also 2 molecules of ATP is produced. So total 4 molecules of ATP is produced in glycolysis. Okay, in this step 2 molecules of ATP, and from this dihydroxyacetone phosphate again 2 molecules of ATP. So total 4 molecules of ATP is produced, but net gain is 2 because 2 ATP molecules are utilized in the preparatory phase.